The Diesel Symphony, Part 1. It takes all the parts to play the song. We said last time that it starts with a bang. We might call the explosion the cymbal crash of the Diesel Symphony. But a lot of other things have to happen too if the engine is going to play its song. And all of those things have to happen at exactly the right time. The first challenge is, how do you get the first bang? In other words, we know diesel engines use compression to heat up a mix of air and fuel to create an explosion, but that doesn't happen by itself. That diesel engine is just a big hunk of fancy metal until it starts making explosions. So we want to learn how the first explosions come about. How does the engine literally, if you will, start? Well, if you think about it logically, that engine can't make compression all by itself. It needs an external source of power to get it going. It needs something to push that piston up the cylinder, generate the compression that results in heat, and eventually create the initial explosion. Remember, our diesel formula is heat plus flammable air and fuel mix creates an explosion that drives an axle. So the key challenge is to bring in enough external power to heat the engine until it will run on its own. It may seem like we're dragging this point out, but understanding this process is crucial to getting what diesel is all about. A huge portion of any diesel system is dedicated to getting and keeping it running. Over the years, many ingenious solutions have been tried. Most common for a long time was the pony motor system, in which a separate, smaller engine was used to turn the big engine. In other words, the diesels were so hard to turn, they had baby engines or ponies mounted right on board. Take a minute and watch this YouTube in which an old school Caterpillar is started using a pony motor, or a pony engine as it would be properly called. You can hear the pony engine starting first, manually turning the diesel until the big engine builds up enough heat and fuel mixture to fire itself. Now notice what's happening there. It's really important to capture this. The smaller engine, the pony, is actually manually turning the big diesel through its piston strokes until it builds enough heat to create its own explosion. So if you haven't done so yet, go ahead, take a look at the video, and when you're done, come back and push play on this video. Only recently has electric power gotten sophisticated enough to harness for starting diesels. And that's why most of the engines you encounter will probably have, instead of pony motors, common engine-mounted starter motors. The starter motor performs exactly the same function as the pony motor did. It turns the diesel through its piston strokes until the engine builds enough heat to create its own explosion. Later, we'll take a look at other innovations to the diesel starting process, ways to heat up the combustion chamber, or ways to initiate an explosion faster, but they're all based on this fundamental formula. Use an external power source to turn the diesel engine until it builds enough heat to generate its own explosions. Speaking of external power sources, let's go back to that electric starter motor. It also needs an external source of power, right? In formal terms, it needs an external means of storing electrical energy, or as we might call it, a battery. And that's what a battery is, right? A device for storing electrical energy. And for us, at least for now, it's enough to say that the battery sends electrical power to the starter motor. Or how much does it send? Well, it sends enough to turn or to crank the diesel engine until it builds enough heat to run on its own. That's why we measure batteries by their ability to crank, or their cranking power, or sometimes you'll hear it called cold cranking power. Okay? So as we start cranking, what's going to happen? Well, the engine has to have a way to get air and fuel into the cylinder, or into the combustion chamber as it's known. This is done through the fuel delivery mechanism and the air delivery system, working together to fill the chamber with air and flammable fuel. The fuel is delivered from a reservoir or a fuel storage tank through a fuel pump and up to a device known as an injector. And just like it sounds, the injector is responsible to inject exactly the right amount of fuel into the cylinder at exactly the right time. The air may be delivered through a charging system, a supercharger, or a turbocharger that pushes or packs the air, forcing it into the cylinder, again in exactly the right amount at exactly the right time. And what is that right time? Well, it's the time the piston is being forced up by the starter motor in order to create compression. So now the first three parts of our diesel symphony are in tune. The battery is pushing the starter motor, which in turn pushes the piston up and down to create combustion and heat. The fuel pump is drawing fuel out of the reservoir, the fuel tank, and pushing it up to the injector, which is dispersing it into the cylinder. And the air system, the supercharger or the turbocharger, is pushing the air into the chamber, all in the interest of creating an explosion. And sometimes it takes a little while to get the explosion going. Let's take a quick break and watch a serious diesel start up after it's been sitting for a while. Notice the hesitation, or to us, sounds like sputtering. But what's really happening there? Well, the engine is working to build up enough heat to generate its own explosions. So go ahead, if you haven't done so yet, take a quick break and see if you can determine the moment when the engine builds up enough heat to create its own explosions. Okay, at long last, we have our diesel engine started and running. As you can already see, it really does take a symphony of individual parts working together just to make Dr. Diesel's famous explosions. And if you have a solid sense of how this happens, you can now move on to a bigger view of the entire diesel engine system. But let's remember, no matter how big or complex the engine, no matter how intricate the individual systems, they all work together for just one purpose: to create an explosion that will turn an axle or a shaft. Everything about a diesel engine, everything we have learned, and everything we're about to introduce exists only to either initiate or support that process. It's as old as Dr. Diesel's work and as contemporary as the latest computer-driven fuel metering system. Let's familiarize ourselves with the broader view of a diesel propulsion system we'll be using to study for a while. This is a diagram of a marine diesel application, a system used to propel a large watercraft or a ship. It's an artist's conception, of course, and some of its systems are unique to the marine environment. For example, it has a seawater cooling system, where a land-based system would only use coolant or fresh water. Let's very briefly review the features of this system based on what we already know about diesel power. We know, for example, that the engine needs some sort of external power source to turn it until it builds enough heat to make its own explosions. On this graphic, the starter mechanism is represented by points 1, 2, and 3, wiring, battery, and starter. We also know that the engine mixes flammable fuel with air to create an explosion. On this diagram, the fuel system is represented by 5, 6, and 7, fuel source, fuel pump, and fuel injectors. And the air system is represented by 18 and 19, air intake and air turbocharger. In the next unit, we'll start looking at these components individually, but as you can already see, this diesel engine fulfills our concept of diesel power precisely. It generates explosions for the purpose of turning a shaft, the shaft that's connected to that prop. Hopefully by now, you're feeling very comfortable with that central concept of diesel power. From now on, we'll dig deeper into how it all actually works, starting in the next unit. See you then. Thanks.